This is the video for Unit 2, Lesson 5, Polynomial Division. So the goal that we're going to see today is we're going to talk about dividing polynomials. So when we have a polynomial that has more than 3 terms. So we're going to talk about polynomial long division, which mimics a lot of what we know already about long division. And then we're going to look at a different way to divide that might be a little bit quicker, which is called synthetic division. And then finally, we're going to use synthetic division to factor a larger polynomial. So just kind of a reminder about long division, which you might not have done in a few years. So if I have, let's say, 84 divided by 5, you might remember that if this was an elementary school class, you would, obviously make your division box. We would have a 5. That's going to be our divisor. And our goal would be that we would be seeing how many times 5 can go first into 8. We would say 5 goes into 8 one time. We would then say 1 times 5 is 5. I would subtract. I have a 3. I would bring down my 3, or bring down my 4, and then 5 would go into, then you'd see how many times 5 divides into 34. We would get an answer of 6. 6 times 5 is 30. You would subtract, you would get 4. And what would happen is we would have a remainder of 4, right? So you would either write your answer, you'd make a decimal, maybe you'd bring down a decimal point and go from there. Maybe you would write your answer as 16 and 4/5 as a mixed number. But basically, we would say that 84 is not divisible by 5. That if it was, we would have gotten a remainder of 0. So that same idea kind of falls when we talk about factoring. So when we get a remainder of 0, that means the divisor is a factor. So like, for example, 5 is not a factor of 84, but let's say 2 wouldn't have given us a remainder. It would be a factor. The same thing is going to be true for a polynomial. So we use something called the remainder theorem, which basically says if I divide 2 polynomials and the remainder is 0, then we have something that's a factor. And so that's kind of what we're going to be looking at first, is long division. And then we're going to find that when we're dividing with a binomial, especially if it's a binomial that has just a coefficient of 1, we can use something called synthetic division. So for this first example, I'm going to show it with polynomial long division first. And then we're going to see a faster way of doing it in synthetic division. So like we just saw in the example above, we have these are being divided out. You also might see it eventually down the road when we talk about rationals. Maybe you might see it written like this as a fraction. And so we're going to go ahead and do our long division just like we did above when it was just numbers. So I have here x minus 1. I'm going to write my division box here. And I have on the inside x to the third plus 4x squared plus x minus 6. And just like how we do things in base 10, right? If I have the number 101, I'm not going to write that as 11. Those don't mean the same thing. I always want to make sure that all my place values are there. So like x to the third is there. That I have an x to the second, I have an x to the 1, I have a constant at the end. If I was, let's say, missing an x squared, I can't just jump from x cubed to x to the 1. I'd have to put a 0 in there as a placeholder, right? Because again, 101 and 11 aren't the same. Same thing for polynomials. And we'll kind of see an example like that as well. So the first thing we're going to do is we really just kind of focus on that first term of x and x to the third. So basically, we're going to say, what are we going to multiply x by to get an x to the third? And so remember that if I want x to the third and I have an x already, 1 plus 2 is 3. So I essentially need an x squared. So I'm going to write an x squared on top. And then just like we do with regular long division, I'm going to multiply through. So x to the second times x is x to the third. x to the second times negative 1 is negative x to the second. And then I'm going to go ahead and subtract. So I'm going to subtract. So really it's like taking the opposite sign. So I'm going to subtract. Subtracting makes this now a positive. And this will go away. And I'm now left with 5x to the second. We're now going to do the same thing we did before. I'm going to bring this next term down. I have plus x. And I'm going to do now the same exact thing. So I have here, what do I multiply x by to get a 5x squared? I'm going to multiply by 5x. 5x times x is 5x squared. 5x times negative 1 is negative 5x. I'm now going to subtract. So if I subtract, it's like taking the opposite sign. And this becomes a 6x. And then I'm going to do my very last piece of bringing down my negative 6. All right, and then now I'm on my last piece here. What am I going to multiply x by to get 6x? I'm just going to multiply by a positive 6. 6 times x is 6x. 6 times negative 1 is negative 6. I'm now going to do the opposite, so I got to subtract. I'm left with a 0. And I divided it out now. So when I divide this out, my answer is x squared plus 5x plus 6. Obviously, I could factor that a little further, but just for right now, I'm going to leave it like this, right? Because the question was just to divide it. I divided it out, and that would be my answer. So that took a little bit of time to do, and it could be a little overwhelming. So the nice thing is, since we're dividing by a binomial, and it's a degree 1 binomial, and then it's just simply an x, so 1x, we could actually use something called synthetic division. So I'm going to do the same problem we just did, but now I'm going to use what's called synthetic division. So that's kind of the same thing. We're just going to do almost like a shorthand way. So I have here x minus 1. And if I set that equal to 0, that would be the same as treating it like a 1. So we're going to go ahead and I'm going to put a little 1 as a placeholder there. And I have this polynomial. So for my x to the thirds, the coefficient is a 1. For my x to the second, my coefficient is a 4. For my x to the 1, my coefficient is a 1. And for my constant, I like to put a c for constant. That's negative 6. And so what we do is we set this up. I'm going to put almost like a plus sign. And we're now just going to kind of do some multiplication and addition. So I'm going to bring down my first term. I have a 1. And now what we're going to do is we're going to do 1 times 1. 1 times 1 is a 1. And now I'm going to add 4 plus 1 and get 5. Now we're going to do, well, what's 5 times 1? 5 times 1 is 5. 1 plus 5 is 6. And then now I'm going to do 6 times 1 is a 6. And this gives me a 0. My final answer, it's always 1 degree less. So if this is the x to the third column, this is actually x to the second. If this is x to the second, this is an x. And if this is x to the 1, this is my constant. And if this is my constant, this would have been my remainder. You can see I have a remainder of 0. So my final answer would just be 1x squared, or essentially x squared, plus 5x plus 6. So I got the same exact answer that I did with the long division. The same thing is true for if I have it just straightforward. This one's an x minus 2, so it's almost very similar. So if it's something bigger than 1, that's fine. So I would take the opposite. So this is really like saying 2. So I'm going to go ahead and put a 2 here and do the same thing. So what happens with this one, though, is I have x to the third. My leading coefficient, that's a 1. You can see in this one, though, I don't have an x squared. So this is really the same as saying 0x squared minus 6x plus 4. So I have to put a placeholder in there. Again, the same reason why 11 and 101 aren't the same number. Then I have an x. I'm going to put a negative 6. My constant is a positive 4. And then now I'm going to do the same thing I just did. So I'm going to bring down the first one. 1 times 2 is 2. I'm going to add and get a 2. 2 times 2 is 4. I get a negative 2. Negative 2 times 2 is negative 4. It's a 0. And everything's 1 degree less. So if this is x to the third, that means I have an x squared. If this is x squared, that means that's going to be a 2x. If this is an x, that means this is my constant. And then my remainder is 0. So it was factorable. And that's it. So this is the you try. For it, we're going to have you try that out. And then the next step we're going to look at is synthetic division and factoring. So for the synthetic division, we're going to do the same exact way. We just are now going to make sure that we can, if we can factor all the way, we want to go ahead and factor all the way too. So the first thing that we're going to see here is it says factor, and we have a 4-term trinomial or a polynomial, and we don't have a GCF. We could try to do some grouping, see if that works, but they also tell us we have a factor of x plus 2. So we can go ahead, and what that means is I can divide x plus 2 into this and get something that doesn't have a remainder. So that means we're going to actually do synthetic division. So I'm going to take the opposite sign, and this is a minus 2. I'm going to list all these out. So my x to the third, I have a 1. X to the second, I have a 9. My x, I have a 24. My constant, I have a 20. I'm going to go ahead and do my synthetic division. 1 times negative 2 is negative 2. That's a 7. 7 and negative 2 is negative 14. That's a 10. Negative 2 and 10 is negative 20. So it does divide. I'm left here with x squared plus 7x plus 10. And then we're going to see, now, can I factor it further? So it doesn't, does it have a GCF? No, it does not. Is it grouping? Nope. It's also, if we look at it, it's actually a trinomial. So I can try to see, is there factors of 10? If I do the little house guy, factors of 10 that add to 7, we actually have that I can use 5 and 2. So I have x plus 5, x plus 2. I don't have to do extra grouping because the leading coefficient's just a 1. And then if I factor it completely, I still had an x plus 2 that was here too. So you can either write your answer like this. This is your final answer because I had to put that factor in there. Or you might also have written it, since there's 2 x plus 2's, x plus 2 quantity squared times x plus 5. Both would be correct. For the last example, it's almost the same thing. So we're going to go ahead and do our synthetic division first. So I'm going to take the opposite, and that's going to be a 3. I have 6x to the fourth, negative 3x to the third, negative 41x squared, negative 2, and that's an x, and then negative 30 is my constant. And then I'm going to go ahead and do my synthetic division. I get 18. That's going to give me 15. When I multiply by positive 3, I get 45. So that'll be a 4. 4 times 3 is 12. So that will give me a 10. And then I get a remainder of 0. Now when I write this out, I actually have here 6x to the third plus 15x squared plus 4x plus 10. And now I'm going to try to see if I could factor. So I'm going to ignore this one just for a moment. And I'm going to ignore this, but you still have to do the, actually I'll just rewrite it over here. And now we're going to go ahead and go through our steps. So do I have a GCF? I don't have a GCF. Can I do grouping? Well, let's check it out. I do have 4 terms. And it looks like we could do grouping. So this is 3x to the second. So 2x plus 5. This I can pull out a 2. 2x plus 5. The parentheses match. So I got 2x plus 5. 3x squared plus 2. And then in the front, I have to make sure I put that factor I pulled out in the beginning. If I want to factor it completely, this is x minus 3. And this would be my final factored answer. The U-tries are very similar, so you want to make sure you complete the U-tries. If you have any questions, feel free to ask them in class. Sign up for T-Bolt time or go to the center.